Yeah, hello everyone. First off, yeah, it's missed my target date for trying to get a video out. Let me give you a bit of advice when you're working on projects. You know, you can get sidetracked so easily. I was trying to do something and then I ended up looking at something else and then I ended up doing something else. So it just kept sidetracking myself. I guess we all goofing off in the garage. So this is something that we just but of course, my intention is to try to get more content in a timely fashion out. You know, this particular mini-series, I guess, the two videos, this one and the previous one, is primarily just for me to share with you all what I use for my benchtop, you know, circuits and whatnot. It's by no means meant to be a all-in full video of what a lab bench should be, but it's something that I think, you know, 90% of the stuff that I do I can get away with what I have, and that 10%, you know, I just don't even go there because it's probably too involved anyway. So you know, I guess one thing about home workshop doers is you know, we don't have a lot of time to spend, and so what we have, you know, we want to make the fullest. So today we'll look at the power supply behind my shoulder here. This one is something that I built a couple years ago, so it's actually sat there for 2 years. It's worked flawlessly except for a couple points which I'll raise in the video to come. And I hope you'll enjoy it, just to see, you know, there's a few design elements that I did a couple years ago which I didn't note at the time because, again, I had no knowledge that I would be doing YouTube videos for my friends out there in the YouTube land. But you know, don't hold it against me. I think with what you see, you should be able to design or something close to it. So let's, without wasting time, I guess, let's jump right into it, and I'll see you guys on the bench. Alright, so we're looking at now the power supply, which I'm going to show you here on the bench. As you know, we looked at this the other day, and now we'll take a look at that. I'll just show this to you briefly, which is the one that I'm using, but that doesn't, you know, at the end of the day, it's just a matter of what type of multimeter you're using. I'm not going to get into the details of the multimeter because there's so many videos out there explaining. This one just happens to be the Fluke 17B plus. It you know, does everything that you need it to do. Definitely one of the more important instruments that you will use. So let me set you up on the bench, take a look at the power supply, and we'll go from there. Alright, so here we are on the bench with the power supply. That thing I pointed to a little earlier was the current limiter that we discussed in the last video. And so now, let me set this up so you get a better view. Alright, so this casing is actually a casing from a digital TV service provider, which never came and picked it up after the subscription ended. So I don't know if we're doing anything wrong, but it turned out to be a great case for the actual power supply module. Now, the way that I did this was, I can get the glare off. It's these two independent DC to DC converters. We'll look at the voltage range here in a second, and then of course the outputs of each one is independent, and it has the on-off master switch, which is a soft start circuit, and then of course here in the back it has the master on-off, which cuts power off to the power supply, which I'll show you in a second is a PC power supply repurposed. And of course, as you know, they have the always on 5-volt on the PC power supply, so we have the a USB port here as well. So let's quickly just get into this, and I'll show you the insides of this this little unit here. This is probably, in my opinion, the 3 units that I showed you. Again, this is all personal. Everybody has their own opinion on what's important and what you should have. But I think that these are the 3 most important components that you need when you're even doing basic electronics. And this one has got more screws than I thought. All right, there we go. And I think this is the last one. Yeah, I'm tearing this off, so the warranty is now voided. So basically, once we get this open, you'll see that it's not the prettiest, but it does its job, its purpose quite well. So let me quickly explain to you what these components are. This board actually was the original power supply board that was in the unit itself, and I repurposed the power supply board to actually feed the power to the start-stop circuit, which we'll go over here in a second. But as you can see, this chunk in the middle here is the PC power supply. It came off of I believe it was a Dell or something, and actually it was thrown away by a friend that said it wasn't working, and I took it apart, looked at it, and quite frankly I couldn't find anything wrong with it. But it's been in this case for over a couple of years now, and it's worked quite well. So the main power, which, if we can look here, comes in from obviously the outlet voltage, and here I split it up into the the always on power supply, which feeds the relay circuit for the soft start stop. Now, on this particular design that I have here, we have the relay circuit, the soft start circuit is here. Now, no, I guess you can't see that. Let me zoom in a bit here. The start stops, the relay circuit here is actually a single push button on and the same button for off, and the way that is achieved is using a MOSFET. The design of this one is actually, I picked it off of another YouTuber, and I looked for the schematics that I used, and in order not to mislead you, I couldn't find it, ironically. And the problem is it is glued in place, so to reverse engineer that so I can give you the schematic was my plan, but unfortunately it's all hot snotted in place and I can't read what particular things I look, but I will look for that. But you can also do a search on the YouTube or even just in general, soft latching circuit or single push button latch circuit, and you'll find it. And basically the only difference of this circuit, what I did versus what was done in the videos, is instead of running an LED, it actually powers this relay. And from that perspective, this one happens to be a 28-volt relay, and the circuit itself is a 12-volt circuit, which is coming off of this board here, which was, like I said, the original board that was in the TV box, set-top box. So this particular circuit, you know, this latch, let me zoom you out a bit a second here. Of course, when you zoom out, you need to do the manual focus on this puppy. If anybody knows how to make the what is that, a Canon EOS T3i, how to make the video recording autofocus, please let me know, because I honestly looked at all the menu options and I couldn't find it. So this LED here actually indicates the state of the power supply. So I used a tricolor LED, so it's red, green, and blue, just for the sole purpose because it was fun. This would be red when this switch is off, which is getting its power from this board here. When the switch is on, meaning it feeding to the computer power supply, this one is blue, indicating that it's ready, and then with the single push it turns green, which powers the circuit completely. Yeah, phone rings. Don't put it on silent, but I guess it doesn't matter. Okay, so where were we? This was the fan that was actually inside the power supply itself. I just hot glued it into place in the middle there, just to kind of blow the air. There's a lot of holes in the chassis itself, so it's not like it's going to be starved for air. And the two power supply modules themselves have their own little fans. You know, they actually do spool up quite a bit when you're pumping some power through these. So let's power it on, and I'll show you the way that works. If I can find the plug. Okay, here we go. I did actually take the plug out and put one of these standard computer plugs in the back here, right there. So it's hopefully I don't shock myself. All right, so now the all right, so there's the capacitors here to run the soft start circuit. They were energized when I plugged it in, so it gave it a different state of reading. So you can see we got the red. Let's move this so we don't get so much glare on there. So this is red, indicating that it's just plugged in, and that module here next to my finger, which I hope I don't shock myself, is powered. And then when I push it once, oops, sorry, not when I push it, when I flip the switch now, so I'm going to flip the switch, and when I flip the switch, it just turns the LED to blue, indicating that it is ready. All right, so now what we have is the PC power supply energized, and then with one push it turns green and it brings on the power to the two power supplies. Now there's one point here that's worth mentioning, and I found out the hard way. These two power supplies are not fully independent, meaning they do share a common ground. So if your intention is to put, let's say, a minus and a plus voltage on a circuit, it doesn't work. And I found out the hard way. This is my second set. I actually burned them out. I didn't think about that at the time. So when I powered it on, I was literally shorting them out, and I burnt the MOSFETs. I did end up fixing those MOSFETs, and I do have a couple of spares which I'm using on other projects. But these are really good little power supplies. You know, you can set it's hard to see. That's my only complaint, is they're very small. It would have been nice to have those bigger, but you know, I'm not going to go into the detail of the power supply itself, but oops, you can set the power supplies output voltage and all that from these knobs here. And for example, the maximum voltage it can go up to, I believe it's 36. It's 36.5. Let's see if I can yank it up. Yeah, 36.5. And the maximum current it goes up to is, I believe it's 4.5 amps, but let's just double check here. No, it says 5.1, so I guess that was 5 amps, but we're getting the 0.1. I don't know if you could see that. Yeah, this doesn't have a stabilizer. There you go. So you can see the 36 volt, the 6.5 and the 5.1 amp. So these output to these banana plugs here, and this one obviously outputs to these banana plugs here. And like I said, these grounds are common, so it will, if you try to do a circuit which requires a negative bias or a negative power supply as well as a positive, unfortunately you can't connect the negative of this one to the positive of this one. It will short one of them out. And so that's so then once you have that set, and then you can just push the on button, and now you've got it on. And the nice thing about these little units is they're current limited, so even at a short circuit it'll limit the current. Well, obviously, as long as you're not trying to backfeed it. And it measures the temperature. Don't know if you can see that, 22.1. That's the temperature of the components inside. So as it heats up, it ramps up the internal fans for itself. So this is the power supply. Now when I push this button again, as I mentioned, it goes into the standby mode, which is indicated by the blue. And then when I flip the switch in the back, it doesn't immediately go to red because of the capacitors in the circuit. If I even switch it on, there's just enough power left to keep it, to give it a couple of ticks, and then it goes to the full off mode. So when when I'm in the garage or just walking around, I just quickly glance over just to make sure that I'm not trying to charge something or burn something when I'm not paying attention. And this is a nice indication that the power is off and that I'm not in standby mode. I don't have a problem with keeping it in standby mode. I guess it's at the end of the day it's designed for that, but again, I just kept the circuit separate. The way that this obviously these LEDs here are running the. Sorry, did I say LEDs? These relays here are running the LED. It's a common ground LED. So the voltage coming out of the power supplies, I separated them with physical relays. Yes, I could have used transistors and done it the modern way, but quite frankly, I do enjoy that clicking sound of the relays when they become active. And obviously, this main power supply is connected to this main relay here, which then energizes the full circuit. So I get a nice, satisfying click out of the relay itself when it energizes. And like I mentioned, this is the main relay for the start-stop button in the front here. There's one point that I do want to mention, but you're gonna not like the fact that I'm not showing you on paper that this circuit, the start-stop circuit that has the MOSFET, I tried using the NPN and PNP transistors. I tried a few. This circuit actually worked out very well. The only thing you should be aware of in the design that I personally find, and I'm going to look for it, I promise, and if I can find it, I will post it in the comments below so you can have a look. But it's one, I had to play with the values of the resistor and the capacitor in order for the latching to remain latched. The principles, again, if you look on YouTube, you'll find how a latching circuit works. It's basically just using the gate function for the MOSFETs to turn it on, and the resistor and the capacitor in series or in the RLC circuit, tricks it into thinking that there's always power, or it's either grounded or there's power at the collector, so it turns it on. And a few times when I first did it exactly as per the schematic, it wouldn't stay latched. It would just click and then it'll just release it. But then I played around with it. Yes, you could have done the mathematics, you could have looked at that and figured out it, but I had a few lying next to me, so I just played and I actually found the right combination that made that work. And of course on all of the relays, don't know if you can see that very well. Where's my light? I don't want to wash it out. Yeah, you can see it. You see that each one has a diode, the flyback diode. That is an issue, especially on these high frequency power supplies. So be sure that you have every one of my relay has a flyback diode, so it doesn't cause a voltage spike into the system. Alright, so that's pretty much in a nutshell. I mean, I was thinking, why we could draw this out on paper, but it's like I said, it's a very simple design. The power supplies themselves, like I said, those 36 volt 5 amp, they are being fed by the 12 volt output. So these are buck boost converters, DC to DC, and I'm using the rails. They had two independent. I don't actually remember what the specs were on this particular power supply. I believe it was a 300 watt power supply. I could be wrong, but it doesn't matter. I'd never use this at those powers anyway. But once you get the two separate circuits are independent, but again, it is common ground, so the ground of both of these are shared. So there's unfortunately, it's not one of those high-end expensive power supplies where you can have multiple minus and plus voltages. This is it. One thing I guess is worth noting is, of course, the cabling, and these are just pre-made banana clips to normal alligator clip style. So obviously the banana clips will fit into the power supply like so, and then here you could just connect to anything that you want to power. I can't explain how much this has been useful for me. Not looking around for batteries. Yeah, I can't explain enough how useful this power supply has been for me. It literally has made life much easier, and the fact that it has a charging function, because you can set constant current or constant voltage. You can safely charge lithium batteries, and I've charged many of these 18650 cells, these famous cells that you find pretty much in everything. So those are just basically look up on Amazon, and I'm still trying to learn the ropes, so I still don't have the links in the description, but you can find these power supplies on Amazon, is where I actually purchased them from, and I believe I paid for these particular ones with the color screens, I think they're $25 each in that area. They actually have lesser expensive models which don't have the color screen, but let's splurge a little. Alright, so that's a look at the power supply, which, like I said, in my opinion is in conjunction with the multimeter for your basic circuits. If you want to power your Arduinos, if you want to power, just simple circuits or even very complex circuits for that matter. These things put out a lot of power. And again, the good thing is you can slowly ramp up the voltage, you can slowly ramp up the current as you're actually in real time as you're powering the circuit, so it makes life a little bit easier. Yeah, so that's the power supply. I'm trying to think if there's anything else I want to share. Oh, of course, with the banana clips, that gives you many options to try. You can make your own little cables. Like this has the 2 banana clips to the 5.5 millimeter barrel plug, which then, for example, if you want to set these buck converters, there's a few projects that I've done that I use a remote battery pack. But while I'm on the bench and I want to set up the buck converter, then I can connect it to the power supply, adjust it to the 16.5 volts or 17 volts that battery supply will provide, and then you can fine-tune this one to whatever output voltage you need. We'll see these in the future in other projects, but for now, yeah, I think this sums up the power supply, and I'll see you guys in a second. So thanks for coming along. I hope you enjoyed that. I hope it was enlightening to some, entertaining to others, and I'm sure there's a few of you that are cringing with what you saw, but such as part of doing things yourself and having a little bit of fun outside in the garage and messing around. I guess I should note that power supply that was in the set-top box itself, it could be any power supply. You don't even need to have that one. That was just kind of there, so I went ahead and used it. So if you don't need that. Just the 2 power supply modules themselves and the computer power supply is really all you need. And then the more you add to it is just at that point up to your desires. I hope you enjoyed this. Again, it's a little later than I was hoping, and I'll try to get more out as soon as possible, and I think you'll enjoy the coming videos. I'm going to try to get one out here soon for something before the holidays, which some of you, I'm sure, have kids that like fidget toys, so I'm going to try to do something for that, and we'll hopefully you'll enjoy it. So see you soon. Take care. Thanks. Bye-bye.